Okay, so our group have chosen set G, and for the first task, we are asked to find the inverse of K1 using adjoin method. Then we are asked to decrypt the message using the inverse, and we have to find if it is the correct message. Okay, so from K1, we have to first find the minor of this matrix. So to find the minor, we have to start off with a minor of row 1 column 1, and then proceed on with row 1 column 2, and then so on, and we have to find all of the minor like this. Okay, so how do we find the minor? So firstly, we will cut these two lines and we'll get the numbers from here, and then for this minor row 1 column 1, we will then again we will firstly take the first number and then put it here, and then we will cut the line of numbers that is connected, that is connected to the number, and then so for this we take the 2 out, and then we cut these two lines, we get 3 2 and 1 3, and then for the second one it's the same, so we take 1 out, and then we cut the line that is connected, line of numbers that is connected to the number, and then we get 2 2 4 3 and so on, and then we can get the minor of row 1 column 1. Okay, so for the others it's just the same method. Okay, then we are able to find the minor of these matrices, and then we will proceed on with cofactor. So how do we do this cofactor? Is by putting the positive negative sign above, and then we will just multiply it and we can get the cofactor. So for example, we take this positive times negative 34, it's still negative 34, negative times negative 41, still it will be 41, and then so all this is the same. Okay, after we find the cofactor, we'll find the transpose of cofactor. So this transpose is just changing the rows and columns. So for instance, we take the first row, and then when we transpose, this first row will become the first column. So to find the transpose, we will take the so transpose is basically just changing the rows and columns. So for instance, we take this first row, so this first row will become the first column, and then the second row will become the second column, and then so on. Okay, and then we will find the inverse of this matrix. So the inverse, the formula is that equals to 1 over determinant times the transpose cofactor. Okay, so the determinant we found is negative 65, and how do we find this determinant is that we just sub in the values of any rows. So for instance, I take the first row, so I just sub in because K1 is given, I take the first row, and then I take the first row of minor, and then I'll just sub it in. So 2 times negative 34, and minus 1 times negative 41. Okay, so why do I minus is because following this positive negative signs. Okay, so after I find the determinant, I can times the transpose one, and I get all this value. But this is not the final answer, because we still have to use this P, which is given, to times with the inverse we found to get the message. Okay, so by multiplying first row, first column, and then so on, you get the final answer, which is this. And this is not the correct message, because this final answer is in fraction form, but the message, the alphabets, are all represented by whole numbers, so it's not possible for us to find the answer, and then we can't decrypt the message.
So for the next task is we need to find the inverse of K2 by using the ERO method, and decrypt the message using the inverse. And is the inverse correct while multiplying with the p? If the answer is no, then explain why not. So to find the inverse of K2, you must first put all the original matrix side with the diagonal 4 by 4. So means 1 0 0 0, 0 1 0 0, 0 0 1 0, and 0 0 0 1. To change the first row, we multiply 1 over 4 of row 1, and when we multiply this one, we need to multiply this side too. This is must to do we multiply with 1 over 4 first, because we need to change the 1 from 4. Next, for the row after we change the diagonal, we need to change the column by step by first column, and then second column and third column. So we must do this first, and then we follow by the diagonal. So for then, we continue with 5R1 minus R2 and 2R3 minus R4, and continue by R4 minus 12R1, and then the result is 1 0 0 0. When this column is done, means you don't have to use this column again. For the next diagonal, we use 4R2, and then we change the diagonal from 1 over 4 to 4R2 by using 4R2 to 1. And then after that, we need to change from 1 over 4 to 0 by using R1 minus 1 over 4 R2, and then negative 1 over 5 R3, and also 5 and negative 1 over 5 R3. Then we can get the second column, which is 0 1 0 0. For the third diagonal, we use 5 R3, so we can get the third diagonal right here. And then when we multiply, we get 0 1 1 0, which the diagonal is already 0. And then for the last one, it is R2 minus R3. Since we can't change 0 into 1, so the matrix does not has an inverse. To prove that the matrix does not has an inverse, we need to find the determinant by choosing either one column or one row. So by here we choose M11, M21, M31, and M41. When M11, we reduce it by 3 by 3 and then by 2 by 2. So 1, we do the plus, minus, and plus. So 1 is right here, same goes to this and this, and we multiply AB AD minus BC. Therefore, you can get the result of 12 for M11, and M421 it's 0. For M31 it is also 0, and for M41 it is 4. And then for the last step, you just multiply the original matrix back, and then like this one, 4 multiplied with 12 plus 5 multiplied with 0, 6 multiplied with 0, and 12 multiplied with negative 4. Therefore, you can get the determinant is 0, which proves that this matrix does not have inverse. And that is why we cannot decrypt the message using the inverse of K2, because it does not have any inverse. Thank you. For the last task is to find the inverse of K3 by using either method, which is adjoint or ERO, and decrypt the message using the inverse. For K3, we decided to use ERO. So the matrix is 3 3 3 4, 2 2 4 1, 3 2 4 1, and 2 5 4 4. So we must put also the diagonal following the steps by task 2. So to find the first diagonal, which is to change 3 into 1, we use R1 equals to R1 over 3 R1. So we already find the first diagonal. To change all of this into 0, we use R2 minus 2 R1, R3 minus 3 R1, and R4 minus 2 R1. Therefore, we can get all of this equals to 1 0 0 0 for the first column. For the next column, we use R3. For the next diagonal, we choose R3 in interchange with row 2. So from already get that 1, this is the first row, so we interchange row 3 equals to row 2, and then we can get the second diagonal, which is 1. And to continue to change all of this, to 0, we just use R4 equals to R4 minus 3R2, and then R3 equals to 1 over 2 R3, and then we continue to change R4 equals to R4 minus 5 R3, R4 equals to negative 2 over 7 R4. We just change row 3 equals to row 3 minus in bracket 5 over negative 5 over 6 R4, continuing with R2 minus 3 R4, R1 minus 4 over 3 R4, R2 minus negative 1 R3, and then R1 minus R3, and also lastly R1 minus R2. Therefore, when we solve all of that, we can get all the diagonal this side and the inverse at this side. So you can see here 1 1 1 1 and the inverse right here. So therefore, to find the message, we multiply P, which is the origin, which is the decrypt message that we need to decrypt, multiply with the inverse that we get, and the answer is 12 0 19 7, 4 12 0 19, 8 2 18 12, and 0 6 8 2. Then we use the table given to decrypt the message, and we get the answer is mathematics is magic, because 12 represent M, O represent A, 19 represent T, 7 represent H, 4 represent E, and 12 represent M, O represent A, 19 represent T, 8 represent I, 2 represent C, 18 represent S, 12 represent M, 0 represent A, 6 represent G, 8 represent I, and 2 represent SC. Therefore, we can get the message is mathematics is magic. The reason why we can't decrypt the message of K1 and K2 is because the final inverse and the answer when we multiply with P is in fraction, and the code given is whole number. So we can't find the mathematics. We can't find the message. So only K3 that can be used to decrypt the message and to find the message by using the code.